Example 3, determining inverse relationships for power functions. If f of x is equal to x cubed, meaning the cube function, and g of x is equal to 1/3 x, is g equal to f inverse. Now, if we have f g of x, which is equal to x cubed, so we know that f of x is equal to x cubed, so that is the outside function. The input is g of x, and we know that g of x is equal to 1/3 x. So that means that the input now that we need to put in for x is 1/3 x, and then we need to cube it. Now when we cube that function, 1 to the third power is 1, 3 to the third power is, in example 3, we want to determine the inverse relationship for power functions. If f of x is equal to x cubed, the cube function, and g of x is equal to 1/3 x, is g equal to f inverse. So in step 1, we're going to do the composite function where f of g of x, which is equal to x cubed, where g of x is the input. And we're using the function f of x, which is x cubed. So now g of x we know is equal to 1/3 x, so we're replacing x to be 1/3 x to the third power. Now 1 to the third power is 1, 3 to the third power is 27, and x to the third power is x cubed. So we have 1 over 27 x cubed. Now notice that 1 over 27 x cubed does not equal x. So immediately right there we can say that the functions are not inverses. But let's just go ahead and look at the other step. So we want to be able to find g of f of x, which is equal to 1/3 x. So that means f of x now becomes the input for x. So we're plugging in x cubed in for x. So we have 1/3 times x cubed. So g of f of x is equal to 1/3 x cubed. And therefore, 1/3 x cubed does not equal x. So we can see that these functions are not inverse. Now the correct inverse to the cube is, of course, the cube root of x, which is equal to x to the 1/3. That is, the 1/3 is an exponent, not a multiplier.